Chris Bloom here, and if you're a network engineer, you're gonna wanna watch this video. We are gonna do a deep dive on flow analysis, so let's dive right in. This is the flow view in LiveWire. I've opened a trace file. It has analyzed all the packets, put them into a flow list like this, correlated with all kinds of other analysis. What we're gonna do is go through this flow view and describe each of the columns and then the ways of navigating from the flows view to other analysis and views that are in LiveWire. So let's start from the top, or the left anyway. You can see that the very first column is a flow ID, and they are chronological. By default, the flows are going to be listed in ascending order from the first flow that we identified to however many flows there are. And in this case, you can look it up in the upper left-hand corner, and there were 6,290 flows identified in this trace file. Now, I typically am not going to just look through the flows chronologically. I'm looking at the flows for characteristics like number of events, average network and application latency, things like this, which are also in this view. Let's make our way to the right. Here you've got the client address, the client port, the server address, and the server port. There's your 4 tuple right there. You can see that the client address and the server address are names. If I don't want to see the name though, because I need to see all the IP addresses, maybe I'm looking for an IP address, I can go up to the far right and I can turn off show address names, and I can even turn off show port names. So now it's just the IP addresses and the ports, the numbers for those. Most of us though like to have these on. So now I've got my addresses, my ports. Let's go to the next column, the number of events. This is where I might start sorting the flows view. Sortable on any one of these columns. I mean, I could have sorted on the client address. That can be useful. There's my broadcast address. And that's DHCP and a few others. I could sort on the ports. I want to sort on the events. Which flow has the most expert events associated with it? That could be very interesting. So I've sorted by that. Now I'm going to use another feature of the flows view, and that's the flow view details, or we like to call it the drawer. So I opened up the drawer for this flow, and now you can see more details about this flow. You can click here, and a description of the event, a cause of the event, and the remedy of the event will be displayed. In this case, we've got a couple of duplicate acts and some keep alives. Also, we can look at the network latency and average application latency and response time for this flow. Most of us know what network latency and application latency is, but just as a reminder, the network latency is how long it takes for a request to get an ACK back, and the application latency is how long it takes to send out a request and get the data back. You might get the data and the ACK back in the same packet, but oftentimes you're going to get the ACK back immediately, and then the data is going to come back when the application on the server is ready to send that data back. And that is what I typically use the flows view for, is to see what flows have the greatest average network latency and average application latency. And we'll get to that in a minute. First of all, columns are, of course, my favorite. I think the most useful columns in the flows, and probably the most useful analysis that LiveWire does with flows: network latency and application latency, because it does minimum, maximum, as well as average. LiveWire displays the average by default, but you can also display the other columns if you prefer. In fact, let's go ahead and cruise over to the ... in the column header, and you will see there are many different columns that you could display as well if you have a really big monitor, or you get rid of some others. You notice we can do client and city, longitude and latitude, client packets, number of hops that flow has made. We have some wireless fields, and then here towards the bottom we have all of the different latency fields, including best, worst. Then we have different client to server, okay, and the TCP status. Speaking of status and how many packets you have for a flow, if we go all the way back to the top here we have a lot of flows that only have a few packets. So we don't have a three-way handshake, we don't have a status, we don't have, in some cases, we don't have network and average application latency, right? You do need a certain number of packets to have some of these analysis. You also need a certain number of packets at the beginning in order to have some of the analysis. Like if I again go all the way to flow ID, I sort by the first flow, you'll notice some of these don't have a three-way handshake. In fact, none of them have a three-way handshake, most likely because we started this capture after the flow had already begun, right? That's how you're typically going to start a capture or even do a forensic search, is starting at a particular time, and at that point in time, some of these flows may have already been started. Well, they will definitely have already been started. So as we scroll down, there we see our first three-way handshake, a little bit further down, like so. We've looked at all the columns, we've opened up the drawer, I've described some of the analysis we do, the names, the latency. When I opened up the drawer, you may have noticed a button up here called the Flow Visualizer. And that is the typical workflow. Usually look at the events, look at the flows, and then go over and sort by average network latency. Because first I want to see if my network latency, what it is, if it's high. And I do have a couple outliers here with some high average network latency, but as you can see, it tapers off very quickly, and our network latency is under a second pretty quickly. Although, network latency of 429 milliseconds or hundreds of milliseconds is still pretty high. That is something we're going to want to look at. Typically, your network latency should be in the 45 millisecond range. Let's scroll down here a bit. I know it's moving pretty quick, but you can see we taper off even more to the 86 millisecond range and so on and so forth. Okay, so I look at the network latency. Now I have a feel for that. I got my outliers. I understand how the rest of the flows look in terms of network latency. So then I'm going to sort by application latency. Same kind of thing. I want to know what the flows are with the highest latency. If I have a lot of flows with high application latency, and how quickly that tapers off. And then I'm probably going to want to investigate the flows with the highest application latency. Now, if I had super high network latency, or there's a particular flow based on an IP address that I did this forensic search on, probably going to look specifically at that, because I want to know, is the latency, the overall latency or performance of this flow low because of application latency or network latency. And I also want to achieve mean time to innocence, and hopefully that's the case, by looking at the network latency, making sure it is low. So I'm off the hook because I'm a network engineer, and I don't want the problem to be on my network, because then everything's going to have a problem, right? If your network latency is low, then application latency is going to be low everywhere as well. So we look at the average application latency, and I see here I've got some applications, HTTP, with 2-minute latency. Wow, we're gonna have to look at that. Now, that too tapers off pretty quickly. And go to, I've got a YouTube flow with minute 19. I've got a Google flow with 59 seconds. So at this point, how do we drill down into that? That's where this button comes in handy. So let's take a look. I click on the flow. It brings up the drawer. At the top of the drawer is a button called Flow Visualizer. And by the way, this flow is reporting slow server response time. I think we knew that. Now, we may have come to look at this flow because we looked at the expert events first and we saw, hey, slow server response time, let's dig deeper. Or we may have just come into the flows view and sorted on the application latency like we did. And now we're going to hit the flow visualizer, and we are now focused on just that flow. This is a fantastic view. This gives us a ladder diagram with the requests and responses broken out individually, which make up transactions, right? A request goes out, a response comes back, maybe it's an ACK, maybe it's data, but that pair is a transaction. We're looking at the transactions in the flow as well as, and the different characteristics about each one of those transactions. For example, here you can see we have a client request going out to the server. Server comes back with an ACK and a SYN. In fact, what do we have here? Well, this is the three-way handshake. How do I know that? Well, over here to the right, under summary, we have a couple of flags, values, and the first one is that this is IP, and the length is 52. This is the length of the whole packet. Then we have the TCP flags. Here we've got our SYN, we've got our ACK and a SYN, we've got another ACK, we've got an ACK and a push, then we have our FIN and our reset. So they're all unique, so they're really easy to identify. So you're gonna have your ACK, your push, your SYN, your FIN, and your reset. Then we have over here, further to the right, oh, by the way, yeah, we also have our, this S equals, that's gonna be your sequence number. Then we're gonna have your acknowledgement over here. So sequence is 0, of course, and then the acknowledgement was 1, sequence is 1, so on and so forth. Then we get an acknowledgement, now it's 207. And that way we can track our sequence numbers and our acknowledgements throughout this flow. So then we keep going over here. We've got the window size of the client and the window size of the server. So that's really important to track as well. In this case, our window sizes were plenty big, so the slow server response time was not caused by a window size, most likely. What did cause that? We can see that this packet here took too long because we got a slow server response time event. Now, looking at the relative time column, I see that we start with 0, and then every one of these times are relative to the first time. I don't find that as useful as delta time, so I like to bring that up immediately. Now that one response sticks out like a sore thumb. This is 2 minutes from the previous packet. Now I can see slow server response time, and I then would probably from here go to that packet. Boom. I'm now looking at the packets view, but I'm at packet 289,342. I didn't have to scroll there. I didn't have to find it. I used a workflow starting with the flows view, sorting on the average application latency. Oh, wait a second. Let's just do that. But I didn't have to scroll all the way to the packet number 289,342 to find this. Instead, I started with the flows view. I sorted on average application latency. I clicked on the drawer, I went to the flow visualizer, and from here, I then was able to go to the packet. That is a very common and useful workflow. I highly recommend using that workflow in LiveWire to troubleshoot performance issues with flows. Now, what's the problem? Why do I have slow server response time? Well, there's a few other things we can do. Let's go back to our flow visualizer, and you'll see there's a couple other views here associated with this. One thing we can do is look at the payload view. So in the payload view, we will strip out all the binary stuff, all the headers, what do we got? Ethernet, IP, TCP that's in here, and just put the payloads together. And in this case, look, we've got a GET, and then we've got the response back. And it happens to be in text. You know, a lot of the payloads are going to be binary, but in this case, we actually did have text. Maybe it was SQL. There's a lot of text it could have been that will help us either determine the latency ourselves, the reason for the latency, or to provide this type of analysis back to the service provider, the application developer, the vendor, whoever it is that we want to solve this problem, so we can actually go and help them, not just by saying your application's slow, but here in this case is the HTTP request that was sent to the server and the response it got back. Now we also have 5 graphs. We have just the throughput. Here's the latency. It's a very short flow, so these aren't going to be the most interesting graphs. The sequence numbers, the TCP trace, and the TCP window. The TCP window can be very useful if you earlier had seen that the window size was going down or it actually got to 0, in which case your client or your server has run out of buffer space and is not able to send any more packets or receive any more packets until that buffer space is freed up. So the application is running very slowly and is not able to clear out the buffer quickly enough. So those are the views that we have here. We'll go back to packets, which is the flow ladder diagram. And the final ... over here is just a few things you can change. You can show absolute sequence acknowledgement numbers like so. So you can change a few things over there. You always want to be looking out for the ... in LiveWire. They're everywhere. And since we don't have a right click, the ... is used to let you know there are more options. So that's it for this episode of Deep Dive. Stay tuned for my next video in this deep dive series on LiveWire analysis and workflows. Talk to you soon. Bye.